Hello, and welcome to today's statistics lesson. We're going to look at a binomial probability again, but we're going to look at something where we're not asked exactly what's the probability of something happening exactly a number of times. We're looking at a probability where something happens at least some number of times, which is a higher probability because the probability, in this case, we're going to look at a test question. If you have 5 questions and you're guessing, the probability of getting one right exactly is lower than the probability of getting at least one right. So we're going to take a look at that, and this will use that function in your calculator. We use the PDF when we're talking about exactly, but when you're talking at least or at most, this is the function you want to use, and it's in that same second var because that's the distribution calculations place. But it's B instead of A. When you use the PDF one, it was A, and it would find the probability of getting exactly, in the case of this question, this word at least, if I were looking for the probability of exactly 2 questions, right, correct, I would use the PDF. But when I read this question, I see a quiz consists of 5 multiple choice questions. Each question has 4 choices. A student who forgot to study. Oh no, that never happens. Guesses randomly on every question. At least they answered every question on a multiple choice test. It's very annoying when you leave one blank. What is the probability that the student answers at least 2 questions correctly? Using this function is actually pretty easy, but you have to make sure you're answering, you know what question it answers. When you use this function, you put in the same parameters you would when you're using the PDF. You put in the number of trials, the probability of a success, and then you put in the number of successes, X. Now when you do that though, this gives you, so if I do n equals 5 for this question, and P of a success is 1/4, and X is 2, this will give me the probability of getting 0 plus the probability of getting 1 right plus the probability of getting 2 right. And that's not what I want. I want the probability of getting 2 right plus the probability of getting 3 right plus the probability of getting 4 right plus the probability of getting 5 right. So when I do this, what I really need to do is I need to find out what's the probability that X is less than or equal to 1. And to do that, I put in that binomial CDF. I use n is still 5, that won't change, and the probability of success is still 1/4. But I'm going to put a 1 because that gives me the probability of getting none right plus the probability of getting 1 right. What I want is probability of 2, 3, 4, and 5 or more than that 1. And this set of probabilities plus that one has to add up to the distribution. It has to add up to a 1. So once I get this, I know I want to do 1 minus the answer that I get from the CDF function. And I'm going to put big parentheses around this, plus P of 1. So let's use that binomial CDF to find what we're looking for. And when I do that, I get 0.633. So that's the probability of getting 0 right or 1 right. What about the probability of getting 2 or more right? Now, your gut feel should say that's less likely. You're less likely to get more right if you're guessing, but the real reason is because 1 minus 0.633, and that's a 6, is 0.367. That's the probability of getting 2 or more right, but you find it by finding the probability of getting 1 or less right using the CDF function, and then you have to subtract 1. So that's the kind of the trickiest thing with using the calculator and the cumulative distribution function for students is you have to decide which way are you accumulating. The cumulative starts at 0 and goes to whatever number you put in. If you want the ones beyond that, you have to find this and then do 1 minus it to get the answer. Okay, that's all I have for today. Email me your questions. Hopefully that will help you with some of the homework.